So there's a few things we know and a few things we're trying to find out. And we're going to use some math to kind of get us there. So what we do know is we have a small sprocket at the front and a large sprocket at the back, and we're going to put a chain between those. And as you know, as this sprocket, the small sprocket, will be driving the big sprocket. So this is the motor, and this is the axle. So our motor right now, or originally when I got this quad, had 16 teeth on it. And the rear has 34 teeth. So that's the ratios that it is 16 to 34. Every 16 teeth to 34 teeth. I've purchased different sprockets, one at 13 and one at 40. So those are the four sizes of sprockets that we have to deal with. Another thing we know, this motor has an advertised 72 RPM per volt. So 72 times, we want this to run at 48 volts ultimately, 48, so 72 times 48 equals 3,456. At 48 volts, if everything's working perfectly, and this with no draw on the motor, this is just free running on a bench, the motor should spin 3,456 RPM. What will it spin under load? I don't know. That's one of the things I need to figure out. I'm hoping there is some data someplace on this motor that tells me at a certain amperage draw what speed the motor's going to go. There's a thing called CEMF that limits the speed of a motor based on how much current is being drawn. So I may get into that. I may see if I can find those numbers, but I think I want to be a little more experimental than that, but you'll see what I mean when we go. So if the motor spins 3,456 times, or times in 1 minute, this ratio here will decide how many times the back axle is going to spin. So I'm going to take all four of these ratios, and I'm going to just kind of we're going to figure out mathematically what the ratio is between them. So if I take the 40 and the 13, that ratio is 3.07. If I take the 34, this one, and the 13, that ratio is 2.61. If I take the 40 from this end and the 16, that ratio is 40, 16, that ratio is 2.5. And the last one, 34 and 16, and that ratio is 2.125. I got these numbers by dividing one by the other. Divide 40 by 13, you get 3.07. So for every 3.07 times this motor goes around, this axle goes once. So these numbers up here, the higher this number, the more times the motor has to turn. And that gives you a higher sprocket ratio. That increases torque, as you'll learn in powertrains, but it decreases speed, and I think that's what we want. With taking this number through these ratios, this axle would spin 1,125 times. This one would spin 1,324 times. This would spin 1,382 times. And this would spin 1,626 times. So as you can see, there's a big difference between 1626 and 1125. That's what, 500 RPM difference. That's almost 50%. That's like 40% of that number. So we're talking speed differences of 40% depending on the ratio we use. Now we need one more thing. We need to figure out how far the vehicle goes every time it goes around. So at 1,125 times, if it goes around that many times in a minute, how far has it gone? To do that, we need the circumference of the wheel and the tire. I don't have that handy with me right now. I'm going to go get those numbers, and I'll come back here and we'll finish off our calculation.